This video will cover making a data frequency table, a one-way table from a data file. You have the information from our class notes regarding the instructions, and I'm going to use the SAT.XLSX as my source data. I'm going to be using SAT scores, and we're going to create a 7-class frequency table of SAT scores for the 50 states and the District of Columbia. So, to begin with, I'm going to follow the method here, in which the first thing to do is to figure out the number, or decide the number of classes in the frequency table. And since I've already said 7, that's what we'll do. Next, determine the class width by dividing the range plus 1 by the number of classes. And so to do that, we'll need to know what the largest and smallest class is, or value is, for SAT scores. So I will create here the largest and the smallest, and then we'll use a Excel function, max and min, in order to let Excel tell me that information. So let's grab the largest, highlighting everything in the file, leaving the label off. It says that the highest SAT score, average SAT, is 1084. Now we'll go ahead and do the minimum, which is just, the process is just the same. Let me clean up my file here a little bit. There we go. We've got it to grab all the data points. And so now we see that the smallest value happens to be 836 average. Let's get the range by subtracting those two. So 184, and of course you could do this by a calculator if you so choose. Now let's do a range plus 1, and so that'll make it 249. And now we need to figure out the class width. We said there was a 7-class table, so we'll put here, I'll just abbreviate width, and it's going to be equal to that value, 249, divided by 7. You'll notice that it comes out to a decimal, which it often does. We round up to the next largest, and so the actual class width is equal to, and I'll expand the column so we get our label in place, will be 36. So that's our actual class width. Now we're ready to go. We've taken care of steps 1 and step 2. Now we begin with step 3. Select the smallest score as the first lower limit. So I'm going to create the table right here in my spreadsheet. I'll create the lower limits on this side. We'll put the upper limit for each class on that side. There'll be 7. I'm just going to use letters to keep from putting in numbers and confusing myself. So here's an A, B, C, D, E, F, and G. 1, 2, 3, 4, 5, 6, 7. We're good to go. Just do a little bit of formatting there. Alright, the smallest value, now remember from step 3, put the smallest value there. So I'm just going to type in 836, and that value comes from the smallest value we have in the data table. Now, the next lower class limit is equal to that value plus the class width of 36. I'm going to anchor that by pressing the function for key, and notice that it inserts $signs, and we're ready to go. Now I can autofill by simply dragging that down, and now I've created all 7 lower class limits. Now, upper class, that's the next challenge, or the next task. Okay, we've done steps 3 and 4. Step 5, we've got all of those. Now we need to enter the upper class limits, and that's going to be 1 less than the next class's lower limit. So in this case, it'll be 1. I can read 871, and then we'll go ahead and do the same process, and that is to add to that the class width, and that gives us our next class, and 907 is 1 less than 908. I can autofill this. Oh, forgot to anchor it. My mistake. So there we have it. Now I can autofill it, and we're good to go. So notice that every value between the largest and the smallest does fit in our table. Therefore, it satisfies our collectively exhaustive and mutually exclusive criteria. Each value can fit into one and only one class, and every value can fit into at least, or can fit into one class, and no more than one. So we're ready now to go ahead and let Excel's histogram function do our tallying for us, because that is step 6, represent each score by a tally in the appropriate class. So we're going to do that right now. Here's my table. I'm going to go to my Data tab, Data Analysis, select Histogram. We're ready to go. It needs the input range, so I'm going to go grab the input range from my data sheet. I'll start here in column B. I'm going to take it up to the first value, put that in place, and now the bin range. The bin range is our upper class limits, and so I'm going to highlight those right there. They're good. No labels. Output to a new sheet. We'll do that. I'm going to ask it for a chart, and that way I can visually see how the SAT scores are distributed. And now we have that. Here's my counts, my frequency counts, 6, 12, 8, 5, 12, 5, and 3. Notice that there are no values greater than our top bin range. That's good. We know that the total is going to be 51 because it's all the states plus the District of Columbia, but I'll double check all of that by simply adding up those values, and now we have our 51. Now I'm going to create a relative frequency column here, and that's nothing more than taking each individual frequency and dividing by the total, anchoring that as well. And so we have everything in place. I can alter it, adjust it down to, let's make it down to 4 decimal places as a common point. So we see that the probability of selecting randomly a score from that list of 51 that would fit into that first class is essentially 0.1176, or I have an 11.76% possibility that that randomly chosen score will fit into that group. Now let's move the histogram chart off to by itself. There we go. And so as I look at it, I see that it does have a bit of a bell curve or a normal distribution nature to it. However, there's a couple of values here in this middle range that are really taking away from the true curve shape that we would like to see. But be that as it may, we have our data, we have our table, and now we're completed. We've done everything we needed to do.